Having robots help us in warehouses and potentially even at home has been nothing but a dream for obvious reasons, until just very recently, when new advancements in the field of robotics painted a very clear picture in which robots can safely and intelligently work and live among us. Mark Zuckerberg announced last week that his company will change its name from Facebook to Meta, with a new emphasis on establishing the metaverse. Creating a sense of presence in the virtual world will be a distinguishing aspect of this metaverse. Presence might simply be defined as engaging with other avatars and feeling immersed in a foreign environment. It is also like to entail feeding haptic feedback into robots for them to intelligently react to touches, and creating some type of haptic feedback for users when they touch or interact with virtual world things. When you smash a ball in Nintendo Wii Tennis, your controller used to vibrate in a rudimentary form of this. Welcome to today's episode of AI News. In this episode, I will show you what this new revolutionary robotics technology actually entails, what it can do, and finally, what this means for the future of the robotics industry and society itself once robots are getting tightly integrated into it. As part of this, Meta AI, a branch of Meta, plans to use a robot finger sensor called Digit and a robot skin called Reskin to assist computers learn how to touch and feel like humans. Mark Zuckerberg stated in a Facebook post this week, "We created a high-res touch sensor and partnered with Carnegie Mellon to construct a thin robot skin. This takes us closer to having realistic virtual items and physical interactions in the metaverse." Robot touch, according to Meta AI, is an intriguing study topic that might assist artificial intelligence improve by obtaining input from the environment. Meta AI hopes to advance the area of robotics by focusing on this touch-related research, as well as use this technology to include a feeling of touch into the metaverse in the future. Robotics is the crossroads of AI research, where researchers are attempting to close the loop on observation, reasoning, planning, and action while also receiving input from the environment. Further, I believe that knowing how actual items feel is critical context for AI assistants like Siri or Alexa to comprehend if they are to one day aid people in navigating an augmented or virtual reality. Machines' current perception of the world is not very intuitive, and there is opportunity for development. For starters, machines have only been trained to receive visual and auditory data, leaving them unable to receive any other sense input such as taste, touch, or smell. That's not how humans function. From a human standpoint, we employ touch Meta AI extensively. Touch has long been seen as a sense that would be particularly beneficial in robots. However, due to technical restrictions, broad usage of touch has been difficult. The purpose of Digit, according to the study team in a blog post, is to develop a small, inexpensive robot fingertip that can resist wear and tear from repetitive touch with surfaces. They must also be sensitive enough to detect qualities such as surface characteristics and contact forces. Humans can distinguish what they're touching by gauging the general contour of what they're contacting. Digit uses a vision-based tactile sensor to try to replicate this. Digit is made out of a gel-like silicone pad that rests on top of a plastic square and is shaped like the tip of your thumb. Sensors, a camera, and PCB lights line the silicone in that plastic container. The silicone gel, which resembles a disembodied robot finger, causes shadows or changes in colors in the emerging image captured by the camera whenever you contact an object with it. In other words, the touch it detects is graphically portrayed. What you're truly seeing is the geometrical distortion and shape of the thing you're holding. You may also deduce the forces being applied to the sensor from this geometrical distortion. In a 2020 paper, the technology underlying Digit was open-sourced, and a few illustrations of how different things will appear with the Digit touch were presented. Digit can record the impression of everything it comes into contact with. It can feel the jagged, individual teeth on a little piece of Velcro and the minuscule curves on the face of a coin. However, the team now wants to collect additional data on touch, something they won't be able to achieve on their own. As a result, Meta AI has teamed up with MIT spin-off GelSight to commercialize and market these sensors to the scientific community. The sensors cost under $15, which is thousands of dollars less than most commercially available touch sensors. In addition to the Digit sensor, the team is releasing PiTouch, a machine learning framework for touch processing. The touch sensor on Digit can show much more than simply glancing at the thing. According to Mike Lambeda, a hardware engineer working on Digit at Meta AI. It may offer information on the object's shapes, texturing, elasticity or hardness, and the depth of force that can be applied to it. From eggs to marbles, an algorithm can aggregate this data and deliver feedback to a robot on how to pick up, handle, move, and grab various things. Meta AI collaborated with Carnegie Mellon academics to produce a robot skin that matches the Digit finger in certain aspects. According to Meta AI researchers, Reskin is an affordable and disposable touch-sensing skin that employs a learning algorithm to make it more universal. This means that any robotics engineer could theoretically simply install this skin onto their current robots. It's a 2 to 3 mm thick slab that can be peeled away and replaced as needed. It may be affixed to a variety of robot hands, tactile gloves, arm sleeves, and even the bottoms of dog booties to capture touch data for AI models. When you press on Reskin, it has a rubbery elastomer surface that bounces back. Magnetically charged particles are embedded in the elastomer. When you apply force to the skin, the elastomer deforms, causing a shift in magnetic flux, which is detected by magnetometers beneath the skin. The force is recorded in 3 directions, which are represented by the X, Y, and Z axes. These variations in magnetic flux are then converted into force by the algorithm. It also examines the skin's qualities, such as how soft it is and how much it bounces back, and compares these to the force. Researchers trained the system to remove out the ambient magnetic environment, which includes things like individual robot magnetic signatures and magnetic fields at specific locations across the world. Understanding pixels and appearances is what we've gotten so good at in computer vision and machine learning. Pixels and looks aren't everything. The only way to comprehend the scene is to comprehend the physicality of the items. LeCun indicated that the skin would be beneficial for haptics in the virtual environment, implying that when you touch an object, you might get some input that informs you what it is. If you have one of those fake skin parts, the sensation on the individual can then be reconstructed using actuators. Meta has also been improving its AI's sensory collection in order to accommodate potentially beneficial metaverse technologies. Meta AI announced a new initiative called Ego 4D in October, which collected hundreds of hours of first-person footage that might one day be used to educate artificial intelligence-powered virtual assistants how to help users remember and recall experiences. One major problem we're still working on is getting robots to learn new activities as quickly as people and animals. Machines are awkward, and they take a long time to learn. Reinforcement learning to teach a car to drive itself, for example, must be done in a virtual environment since it would have to drive for millions of hours, cause innumerable accidents, and damage itself several times before it learned how to navigate. Even then, it's unlikely to be that dependable. Humans, on the other hand, can learn to drive in only a few days because we have a very decent picture of the world by the time we reach our teenage years. We understand gravity and the fundamental physics of automobiles. The department's main goal is to get machines to learn that model of the world and forecast different occurrences and plan what will happen as a result of their activities. Similarly, for the AI assistant that will one day interact with people organically in a virtual world, this is an area that has to be expanded out. Virtual agents that may reside in your augmented reality glasses, smartphone, or laptop are one of the long-term aspirations of augmented reality. It assists you in your everyday life in the same way that a human assistant would, and that system will need to have some awareness of how the world works, some common sense, and be clever enough not to be annoying to converse with. In the end, that is where all of this study will lead. Previously, sensing robotic skins required built-in electronics to track the electrical changes that occur when the skin makes contact with a surface. The sole need for the Reskin system is that the monitoring equipment be close by. As a result, the material may be thinner and produced at a lower cost. Currently, the ingredients needed to manufacture each Reskin cost less than $6 per unit if more than 100 are produced.
What's going to happen is robots will be able to do everything better than us. I'm including, all of us, you know. This is really like the scariest problem to me, I'll tell you. Yeah, so I really think we need government regulation here just to, because this is, ensuring the public good is served.
So, what is your opinion on Meta potentially owning such an important part of robotics which is necessary to enable robots to live and work with us, as otherwise, the danger of them hurting us or destroying valuables would be too high? Please tell us your opinion in the comment section below. I would love to hear what you have to say about it. Thank you for watching AI News. We consistently report on the newest technologies that are shaping the future of our world. We'd appreciate you subscribing and watching our other videos. See you around and take care.